On 24, 25, 26, and 27, it was just really too complicated to write on paper. That's not really what I intended, for there to be such really a lot of complexity to the equation. So instead, I'll do another example with just two components rather than having three components with two of them in parallel. But the gist of all of this was to realize that if you have a complex number, real and imaginary part, you have the real part at an angle like that, plus, I mean at an angle of inverse tangent of b over a. And in these remaining two questions on the back, you have radio stations that range from 88 megahertz to 108 megahertz. You use a bandpass filter to filter out these radio stations, each individually, and you do that by having, let's say, a constant capacitor but a variable inductor. So you change the inductance and it changes where the peak in the bandpass filter is. So you filter out one frequency at a time. So if you're looking for the range of inductances that are needed to build a radio, you solve for L and get this expression. So you put this frequency right there and the capacitance over here to find one of the values, the lower or upper limit, and then you use the other frequency to find the other one. In this DSL circuit, it's the breakpoint frequency that you use to determine when to cut off the noise. And I guess the noise technically is really signal, but you just don't want to hear that signal. A DSL has audio and lower frequencies, but the DSL is using higher frequencies above 4 kilohertz. So above 4,000 hertz is where all the high frequency digital signal appears. So if you were to look at it on an oscilloscope, it might look something like this. I know this is oversimplified, but the principle is still the same. You have this low frequency sound wave, and on top of that you have a high frequency digital signal. Now if you have that going through your earpiece of your phone, you'll hear that high frequency stuff on top of this is kind of a high frequency noise with like a modem like sound to it. So that's the answer to part B. So what you'll need is a low pass filter, and to determine what the capacitance is for this, you look at the resistance they give you and you look at the breakpoint frequency that they're defining there, and you solve for C. So it's really not that difficult to solve for C in this algebra expression. It's more of a concept thing in this problem.